Hello, ladies and gentlemen. Welcome to today's session. Today we will go for additional mathematics, kinematics. So in this chapter, we need to master two parts, which first, how to apply differentiation and integration to find the relationship between displacement, velocity, and acceleration. And then second, we need to draw and use the graph of displacement time, velocity time, and acceleration time. For the graph part, majority of the part we already learned in maths, which is 0580 and also physics. So we will see how the questions appear in MS. So the first part is how we apply differentiation and integration in finding the relationship between displacement, velocity, and acceleration. So if you face problem in how to do differentiation, please refer to differentiation video to master all the basic techniques of differentiation. And if you need integration video and how to do integration, you can refer to the link here. If you see the question asking about displacement, velocity, and acceleration, so usually I would strongly recommend you to write down SVA first. When you want to find the relationship from left to right, it's all applying differentiation. And then if we want to find from right side go back to left, then we use integration. When you apply integration, remember, you need to find the value of plus c, unless you are having the definite integral. If you are not familiar with integration differentiation, please refer back to the previous video. If you are okay, then we can continue. After you write down SVA, you list down the information that they give. Let's say they give you displacement, then you just write down velocity, you just write down A, you just write down. Then from this equation, let's say you have acceleration equation, you can find the velocity and displacement equation by doing integration. After that, you can see the question. There are a few keywords that you need to know. For example, if the question asks you to find when it is at rest or instantaneous rest, as long as you see the terms rest, you need to immediately know they are giving you the information of v equals to 0. This thing that you must know. After that, they might tell you this object or this particle change direction. So when will it change direction? You can use v equals to 0 to find what is the time. So then you know what is the time that they change direction. So after we're familiar with displacement, velocity, acceleration, then we need to know what is the difference between this and distance and speed. So displacement, velocity, acceleration, which is our SVA, are all under vector. If you learn in physics, you should know vector include magnitude and direction. So every time you count displacement, velocity, and acceleration, if your answer in plus or minus, you must show, because this positive or negative showing you different direction. But if the question asks for distance and speed, it's a scalar, which is no direction. So if you get distance is a negative value, for example, if you get negative 26, then make sure the distance is just 26. You should change it back to positive only, no negative symbol. Then other than this, any other difference for distance and displacement, if no change in direction, if you have change in direction, then you need to be extra careful. Let's say I go to the right for 5 meters and I come back 2 meters. So if they involve a change in direction here, then you need to count the distance before change direction and after a change direction. So you get is positive 5 and negative 2. Then the distance is 5 plus 2. You shouldn't include the negative symbol because negative symbol show that I go back for 2 meters. So that's why it's 7 meters. This thing will appear only if it involves change in direction. And then for velocity and speed, is just the same. You just make sure when they ask for speed, do not write your answers in negative. Then we can go for the question. The first question, a particle travel in a straight line, displacement from origin given is this. So we know that this is the SVA question, so I would strongly recommend you to write down SVA. And then the information given is S equals to ln 4t squared minus 5 minus t. After that, if the question asks about V and A, I know going to the right is differentiation. So the first question, find expression for velocity and acceleration. So velocity is just a differentiation of these. Differentiate this will become 1 over the baby times differentiate of this baby, which is 8t. And then minus t will become minus 1. Again, if you're not familiar with how to do differentiation, please refer back to the differentiation video. After we find v, we can find acceleration by doing one more differentiation, and this thing involves this t divided by this, so it's quotient rule. After we get the info of these four, then we can find dy dx. Differentiation of v is my acceleration. Quotient rule is this times this minus this times this divided by v squared. Done. Part B. Find the time when particle is at rest. At rest means v equals to 0. Time cannot be negative, so make sure you reject this part. Time that we can get is 5/2. Done. Part C, find the acceleration at this time, so we just subs in 5/2 into my equation. -3/5. Next, displacement from a fixed point at time t is this. So we know it's a SVA question. Then we can do part A. Find a time when the particle change direction. So we know when they talk about change direction, it's about v equals to 0. So we find what is v first. Differentiation. V equals to 0. T is 1/3 and t cannot be negative value. Then part B. Show that the particle is moving toward origin when time is 0. So we need to confirm by using the S and V. S is positive 8, my V is -1. So since displacement is positive, but velocity is negative, thus it's going back. Just like this. Part 3, find the total distance traveled by the particle during the first 2 seconds. So first 2 seconds, they ask for distance. We need to check whether it involves the changes in direction. It changed direction at time is 1/3 only. So that's why from time 0 to time 1/3, we need to count first. So we use S1/3 minus S0. So get this path is -0.1852. So this is for the first part before change direction. Then we need to check from time 1/3 to time is 2. What is the distance that they travel? So we use S2 minus S1/3, which is 7.8148. Then this part you get the answer is 10.18. So we know this is the distance going to the first direction. This is the distance that travel for the opposite direction. Then you just sum them. Total distance, this plus this. So total distance is 10.37. Because distance, we don't care about the direction, so we do not write this negative. Okay, next question involves integration. Because the question gives us an acceleration, so according to SVA, they give information start from the right, means we need to find velocity or displacement or using integration. So they need to give more information. For example, here they tell you when time is 0, the velocity is 50. Because every time we do integration in application, we must find plus c. That's why we need to have extra information. Part 1, they ask you what is v in terms of t. So we just do integration. We need to do adjustment first. Put this up, then we can do integration. Power plus 1 divided by new power, and then differentiate of this plus c. They tell us time is 0, velocity is 50. So we substitute in. So c is 5. Then we can confirm v is, this is the velocity expression. So part 2, they ask us to find what is distance. So distance, we need to find the displacement formula. So over t power 1 will become ln, and then plus 5t. You found that this question is actually a definite integral. So instead of finding plus c, you can directly find the definite integral from 1 to 10. Then you substitute 1 to 1.7. So this is the distance traveled from time 1 to time 10. Okay, next question give you the velocity, but they give you two velocity because this particle went 0 to 4, they travel in this equation. After 4 seconds until k second, they travel in this formula. So they ask for total distance. So no matter how we need to find displacement, we must do integration. So we need to do integration for both of these because you want to travel from 0 to k, definite integral from 0 to 4. And then for this part is, so power plus 1 over new power. And then definite integral from 4 to k. So the sum of these two is 13.4. I tidy up it first. Divide by 1/4 means times 4. Here is negative 16e over time. Then we can substitute in. So I want to find the k, so I put a k on the right, and then this part I throw to the left. 10.0. Done. Of course, some of the question they will give you from V, which means they might ask you acceleration, so you need to do differentiation, and they ask you displacement or distance, then you need to do integration. The info given velocity is 10 sine 2t minus 6 cos 2t. First, they ask you expression for acceleration. Remember, do differentiation. We always write down sine differentiate will become cos. Cos differentiate will become negative sine. So here we differentiate, sine will become cos. So it's 10 cos 2t, and then differentiate the baby, become times 2. And then minus 6 copy, cos 2t after differentiate will become negative sine 2t, and then again times 2. Part B asks you find acceleration when time is this, so you just substitute in. Then key in calculator, you get the answer is 12. If this is a paper 1 question, do you know what is the value of this? So cos, here you can simplify, become cos pi over 2. So we know it's 90 degree according to the cos graph. So pi over 2 telling you this part is 0. So this part is 0. And then sine pi over 2. Sine pi over 2 is this graph. Pi over 2 showing you it is 1. So this part is 1. So answer is just 12. So if this thing happened in paper 1, you need to know what is the value of cos pi over 2 and sine pi over 2. Part C, find the first time at which the acceleration is 0. When you need to solve the thing that contains sine and cos, we make it into tangent. Sine over cos is tangent, so all the number we throw one side. Sine and cos, we group them together. So it will become tangent 2t equals to maybe 5 over 3. Then we can solve this. So 2t equals to shift tangent of 5 over 3. And then tangent is negative, so answers is here and here. It is 1.03, 1.03. So the first answer you will use pi minus this 1.03 to get is 2.112. So time is 1.056. Of course, this part involves trigonometry. So if you are not very familiar with trigonometry, go to the video here to check how to deal with trigonometry question. ABC is the question related to acceleration. Then part D involves the displacement. So we need to do integration. Part D, displacement of particle between this time and this time. So we know that displacement is integrate of this. So integrate means that we need to refer backward. Integrate sign will become the opposite symbol of cos. Then differentiate the baby, we will divide it. And then here, differentiate cos will be the same symbol of sine. And then differentiate the baby, always plus c. But here you no need to plus c because it's the definite integral. Pi over 4 to pi over 2. Then we just solve it. So this part is minus 1. This is 0. This part is 0. This part is positive 1. So answer is 8. Okay, after we done the harder part about differentiation and integration to find displacement, velocity, and acceleration, then we go to the part that we already learned in maths and physics, which is how to use and draw the displacement time graph, velocity time graph, and acceleration time graph. So revise back what we already learned, displacement and time. This show you a constant velocity, and then we can find the velocity by using the gradient of this line, which is the changes of displacement divided by the changes of time, which is the changes of y over changes of x. Then we can find the velocity. How about velocity time graph? There are two things that you need to find. First thing is the gradient. We can use it to find the acceleration, the changes of velocity over changes of time. Or again, is the changes of y over changes of x. And then second thing is area under graph. Area under graph is used to find the distance traveled by this particle. And then by using displacement time graph, we can find the velocity. So they will ask you to use displacement time graph to convert it to velocity time graph. And because we can use velocity time graph to find acceleration, they will ask you to plot the acceleration time graph by giving velocity time graph. First question is distance time graph. So the question says on this diagram shows that the displacement time graph for a runner, draw a velocity time graph for the runner. So we know that from 0 to 50 is a constant velocity. So we need to find the velocity. So we know the coordinate. Final y minus initial y divided by final time minus by initial time. So get this 2. So we know from 0 to 50 is positive 2. Since it's a constant velocity, we just draw a horizontal line. After this, from time 50 to time 65, it do not move at all. So the velocity time graph from 50 to 65 is 0. They do not move at all. And then from 65 to 85, again, is a constant velocity. V is final displacement, final y minus initial y, final time minus initial time. So it's 2.5. Constant velocity 2.5. Then from here to here, it's showing you deceleration. Final displacement minus initial displacement. Final time minus initial time. So we know it's deceleration, so it's negative 3.75. Then we will get these 3 marks. After this, they says find the total distance from here to here to here. They're going one direction and moving 150 meters for going this direction. Then at last, it's going back 150 meters again, but it's opposite direction. But distance, we don't care go up or down. We just sum all the path that it traveled. So it's 300 meters. That's why it's only 1 mark. Next question, they give you displacement time graph and then ask you to find the distance traveled by the runner when time is 40. So when it's going up, it traveled 50 meters. After that, it's going down. From here to here, it's going back 50 meters. From here to here, it's going another 10 more meters. So total is 110 meters. Next, draw the corresponding velocity time graph from displacement time graph. So we need to count the v. So the v is just final y minus 0, final time minus initial time. So this part is 5. So from 0 to 10 is positive 5. And then from here to here, so this part of v is final y minus initial y, final time minus initial time. So it's minus 2. Minus 2 from 10 to 40. Then you gain 2 marks. Okay, next question is the velocity time graph. So we know velocity time graph, we can find distance, we can find acceleration. Distance is using area under graph, and then acceleration is using the gradient. It says that travel in this meter means that you must use relationship of distance, which is area under graph equals to 2775. So here, if you're familiar with trapezium, we know that it's two trapezium. If you're not familiar with trapezium, you can use this triangle, rectangle, triangle, rectangle. Both methods are okay. So if you use trapezium, so we found that these two parallel lengths that have different length, because they have different length, we need to find the average of it. And then times the perpendicular height, 30. This is for first part. For this part, the parallel line is here and here. So we find the average of these times the perpendicular height, which is 30. So this thing is 2775. This part is 1005. 15 times this and this will become 450 plus 15v. So at last we get v is 55. Then next, write down the acceleration of p when time is 40. So what is the acceleration? So acceleration is gradient of this. So you know that it's horizontal line means gradient equals to 0. So the acceleration is just 0 because it's horizontal, no gradient. The next question is again the velocity time graph. Time is 30. Again, is v unknown. The particle travel 800 meters in 45 seconds. So again, is using area under graph to find the value of v. So this is one of the trapezium. Half of 10 plus 20 times the perpendicular height is 10 plus this is another trapezium. Average of 10 and v times 10 plus here is a triangle. So you just have base times height. So this whole thing is 800. 150, reducing times in, 50 plus 5v plus 7.5v. Velocity is 48. Next, they say the acceleration when time is 35. So when the time is 35 is around here. So for part B, acceleration equals to -3.2. Next question. A particle travels in a straight line as it passes through fixed point. The particle traveling at a velocity of 3 meters per second. Continue this velocity for 60 seconds. So it's a constant velocity of 3. So we use a ruler to draw on 3. The velocity is 3 for 60 seconds. And then it decelerates to a constant rate of 15 seconds to 1.6. So it travels another 15 seconds to 1.6 meters per second. Then they say the particle decelerate again at a constant rate for 5 seconds to reach point A. So which means it's already stopped after 5 seconds. So at 80, they will directly go to the x-axis. So they ask you to sketch the velocity time graph for this journey. Like this, you can gain all 3 marks. Next, find the distance between O and A. So we just find area under graph. Is 1 region, 2 region, 3 region. So the first region is 3 times 60. Second region, the last part is triangle. Like this, you can find the total distance. 218.5. C, find the deceleration of the last 5 seconds. -0.32. But because the question requests for deceleration, so deceleration is already slower down. So that's why you shouldn't write the negative. Because if the deceleration is negative, means that it go back to acceleration. Okay, the next question says, a particle is moving in a straight line of a constant velocity 6. So we know that it starts from here. And then at time t equals to 0, it passes through a fixed point A. At time 5, it suddenly changed direction. So that my 6 is until here. This is the first thing that I can confirm. The change direction means that the v will become a negative v. And then it moves with a different constant velocity. Again, means it's a horizontal line. It passes the point A again when time is 15. So when 5 to 15, it travels the same distance so that it can go back to position A. According to area under graph equals to distance, we know that initially it traveled for 30 meters. It traveled for another 10 seconds. So what is the V so that it will cover 30 meters? We know that it is a rectangle also. V times 10 will go back to the same distance, which is 30. So we know that the velocity is 3 and it moves in a opposite direction. So it's -3. So it involves a bit of calculation because you need to know the distance after it changed direction is the same because they go back to position. Okay, part B, they says particles moving in a straight line with constant acceleration. Constant acceleration in velocity time graph is a straight line going up. They says at time t equals 0, it passes through a fixed point with velocity of -8. So -8 is here. Then it says it passes through the point B again, means that from point B, it go to the front and then it return back. Means that this straight line need to ensure that the negative part area equals to the positive part area, and it need to show a straight line because it's a constant acceleration. So we can confirm it's a triangle that have same shape. Since time is 20, it go back to the same shape. So it will be like this. Next question give us velocity time graph and asks us to sketch the displacement time graph. So we know that here to here showing you a constant velocity. Constant velocity in displacement time graph is something like this. But how we know it start from 0, 0 to where? We know here is confirmed 10 seconds, but how far it travels. So how far it travels is based on area under graph. So it go to 60. So make sure from 0, 0, after 10 seconds, it reach 60. After this, from time is 10 to 20, this is again a constant velocity. It travel for 3 times 10, which is 30 meter. So from 60 meter, after 10 seconds, it travel another 30 to reach 90. So you get the displacement time graph, just like that. Okay, so this is everything that you need to know under kinematic, which we already include differentiation, integration, and the graph part. If you face any problem, feel free to comment here, and please tell me to subscribe, like, comment, and share my video. So see you in the next class. Thank you. Bye-bye.